Welcome all. He follows here will take all the time in this chapter. Normal 0 sigma square. And here alpha is the parameter. Even there is a general one where we write xt is equal to mu plus alpha xt minus 1. Sorry, mu plus, here we write this way. Yeah, alpha xt minus 1 minus mu plus Ct. This is the general one. Et follows normal 0 sigma square. This is the normal one, okay? But they're equivalent. We can use the first one. I'll tell you the difference between both representations, okay? Whatever we use. But yeah, just remember this. And this one also you have to remember. Here, whatever there in your course, you accept this. It's not that always will accept this one. Okay. Now, xt is alpha xt minus 1 et. I'll give you one example. Last time I gave you one example. Okay. That is more appropriate for today's class. Because I talked about the time I give. There was no time constant here. See, t is time. Suppose 2021. T minus will be 2020. Using 2020, I want to predict 2021. That's all. This is a random variable anyway. You will get some part deterministic part, but there is a stochastic part as well. Now, when I write this one, xt is alpha xt minus 1 plus et. How we can use this one? Suppose I insert one line. Here what we do is, you study, okay? Suppose this is one time, 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 okay? And I say that I take classes this way. 1 hour, first class, 2 hours, next class, then 4 hours, then 8 hours, then 16 hours. That way, 31 hours. I course the complete in 31 hours. I start with a small class, then I increase the time. If you have time, you are free, then you follow with me. And in 5 days, I will be able to complete your course. Okay. Or maybe it will take some time, but I do this way. And you need to forecast, seeing this data. I double every day and I will not disclose the time I will teach next time. But you will not get exactly this way. Okay. Suppose you don't know about how I teach. That way we'll consider. And you consider this is the time. Any day you can give. First day, second day, third day, fourth day, fifth day. You don't know anything, okay? That is what my plan is. You don't know about this. So how you get data? If you collect data, suppose you attended the first class, I took 1 hour 2 minutes. Second class, 1 hour 59 minutes. 2 hours, okay? Around 2 hours with ET I am writing. Then number 3 is third class. It's 4 hours, okay? 4.02. Then 8 hours. It's 7 point, or maybe 8.2, I can write 7.992. Okay, this is the data you have. You want to forecast, okay? You want to know something here. So now you know that your xt here, t is 5, x5, we'll find x5, but we'll predict for xt. If you take this model, what we want here is, we'll consider only the last one, okay? Only this one. If I write x5 here, I will write this way. This is alpha of x4 plus et. That means, although we have data, I've given here 4. Sorry, not this. I have this, the recent one. So predict only taking this one. I want to predict here. Though this is a random variable, we normally say the average one, we predict. Even in regression also, we predict the average one. Okay, that you have to know. We don't say exact one. So in terms of EX5, we'll predict. EX5 will be, because we have considered this a 0 sigma square, this will be 0 expectation. Expectation of this will be alpha E of x4. Okay, E of x4. So if you know alpha, you will be able to predict this one. Okay, at least the average. You can specify confidence interval also. You will see the graphs. Suppose you see this way time series, they provide a confidence interval for future. Okay, you can give 90% confidence that the movements will be this way. Okay, this way we predict also. But yeah, you will not worry about that. This is a random variable. Remember this, there is a error part here, stochastic part, there is a deterministic part. Now this is markup because we are using only one step information, though we have data since last 30 days or 30 years. We are not using only one step. So there is a question, when you have data available for like last 1 year or maybe 30 years or 30 months, whatever, 30 days, why not use all data? Okay, so it's not that we are not using all data. When you estimate the parameter, this parameter alpha, when you estimate this parameter alpha, okay, then you have to consider the whole data. So that is a part of estimation. We'll not go to that now. Don't worry. Okay, just remember, if you know alpha, then again remember, when you estimate alpha, all the data will be used anyway. But in the formula, suppose someone has no idea about time series, we can say this one. See, this is what happened yesterday, right? You say me yesterday's data, I will be able to produce tomorrow's data. That way I can say. So alpha, that's a background thing. Why I need to say him what is alpha? I mean, how I estimated alpha. I will say this is normally this way. Okay, this is what I knowledge. Like 2 times I've given. I started with this example, right? So 2 times. I mean, who has attended already the class? Okay, for the new guy, he will say, see, this way it will happen. Okay, yesterday if you attended 7.9 to whatever, you give me that, I will be able to say tomorrow's expectation. So it's very simple. But when it comes to estimation, a lot of things will come. We'll go to that, how to estimate this one. So this is simple. AR1 we say, AR1. Then we'll go to AR2, we'll go to ARP. Again, I showed you 2 types. Okay, I showed you 2 types. Let me write the first type and second type. If I say this way, mu plus this is Google Jamboard. Sometimes it's useful. See, like this. No, I forgot or what? No problem. No, let me not waste your time. I will learn properly. Okay. So now xt is mu plus alpha xt minus 1 minus mu plus ct. So this is the general one. If you want to analyze using this, then what will happen? You can say this way. If you make an analysis using this one, here what we say is, suppose at this point, this is the value. 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 And you want to predict here. So what we say is, you take the average one. Okay, whatever you have, you take the average one already here. Plus, if you want to estimate this one, you can take simple average, whatever way it happened already. We are here. Remember, we are here. The data is available up to this, and you need to forecast for future. Okay, here. Now, my estimation for mu is the mean of the stochastic process. But we are here. We know only up to this. The process is running. It will continue to run in future also. Whatever data is available, from that you can estimate mu. The simple way is just take sample mean for this one. Okay, stochastic process mean. Suppose 10, 12, 11, whatever happened, you take the mean. That way you will get the mean. So mean is something. Okay, already we got. That will say, suppose 80% of the final estimation. And then what you need to do is, you see the recent one. Okay, if this is t minus 1. You don't know at t, but you know at t minus 1, this value and the mean value. So what you need to do is, suppose you see the stock market movement. Okay, and obviously you like to take the average for last 30 days, that is here. But then sometimes what happens is, due to some reason, there is a large movement up and down. Okay, so that's why we'll not take the whole, I mean, we'll see the difference. Okay, this value and the recent this value, xt minus 1 and the mean value, we'll see the difference, how the recent value is different from the mean value. Okay, so what happened is, yesterday only one parent called me and wanted to know the progress of one student. I said, see, since last 5-6 classes he was not doing well, but yesterday he has done very well, but I'm not sure because in future how you will do. Last day was very nice, I agree, but if you forget about last day, the past is not good. The same thing can, the opposite thing can happen. The last 5-7 days are good, but yesterday only it's not good. Okay, and you want to give weightage to that also. So how you can do, you take the difference and give some weight, alpha weight. Alpha could be 0.1, and remember, for a stationary series, alpha mod is always less than 1. Alpha mod less than 1 for a stationary series. Okay, if you write 2 here, like I took the example, teaching example, that is not a stationary process. Okay, we'll go to that later, but yeah, we'll give some weight, 10% weight or 20% weight to this difference, the recent one, and this here you will bring all the past, and then now you want to say some, I mean, you at least you can say random variable for a time t. What is the random variable at time t? And you can find the confidence interval and mean of this. That is what will, that is the way we'll predict in time series. Okay, we can find the mean and the mean at time t and confidence interval at time t because we know the distribution of this, and that is a part of assumption here. However, the interpretation is this, but we will not write this way because our math will be a bit difficult. In this case, what we can do is, we'll bring mu to the left hand side, we'll write xt minus mu, and in the right hand side we'll write alpha xt minus 1 minus mu, and then we'll write et, and this xt minus mu, for this we'll take another series called yt, and this will be alpha yt minus 1, because mu is constant anyway. If yt is xt minus mu, yt minus 1 will be xt minus 1 minus mu plus et. So now compare this one. This is the easier one. Okay, every time you can do this way. If one process is given this way, you can transfer to this way, and we consider this way actually for all kind of analysis. This is easy because here we have extra mu. So this is the general form though, but we use the easier one, this one. They are equivalent. I'm not saying, that's why I didn't write xt here. Normally if I write xt, then you will say where mu and all this they went. Okay, so I didn't say that way. Now let me write AR1. Okay, AR1 is this xt is equal to alpha xt minus 1 minus mu plus et. Then AR2 I'll write, just commit to memory now, alpha 1 xt minus 1 minus mu up to, sorry, AR2 I've written alpha 2 xt minus 2 minus mu. Again we give some weight here for this difference. Okay, mean value with the last but 2 value difference, you give some weight to this, you give some weight to last value minus the average value, plus the stochastic part is et. Similarly I will write ARP. ARP is xt alpha 1. Okay, if I want to write this way, I have to give you mu also. Mu plus alpha 2 xt minus 1 minus mu alpha 1. This is not good, right? Alpha 1 plus alpha 2 xt minus 2 minus mu. You go up to this alpha p, up to p will go ARP xt minus p minus mu. Okay, this is ARP, but we have a mathematical representation. Okay, we'll do that. ARP, for that we'll bring some notation here. Okay, so the first one is nebula xt. It's a nebula xt. Nebula xt is xt minus 1. The difference between the last one and this one. Okay, so if you find nebula square xt, then what will happen? It will be this, right? Nebula xt, and that will be, here you put xt minus 1, then it will be nebula xt minus 1, and here you put this one once again and the corresponding value here, xt minus 1 minus xt minus 1 minus xt minus 2, and finally this will be xt minus 2 xt minus 1 plus xt minus 2. Okay, so here this is xt. Again we'll introduce backward operator. Backward means what? B of xt means what? This is a notation. It will push one step back. Okay, time t to t minus 1 from here to here. This is xt minus 1. Okay, so if I write b square xt, it will be xt minus 2, twice to the left. So 2xt minus 1 is here. This is 2bxt plus this will be b square xt, and then it will be 1 minus 2b plus b square xt, and this will be 1 minus b square xt. Okay, so finally where we started, nebula xt. Okay, remember nebula xt is xt minus 1. Okay, that is xt minus, here you can write bxt, that is 1 minus bxt. See, in terms of xt we are writing nebula xt is 1 minus bxt. How about this nebula square xt? That will be 1 minus b square, this one, xt. Similarly, nebula nxt will be 1 minus b power n xt. This is the difference operator, nebula. Okay, nebula xt. So we'll use all these to make this representation simple. That's all. Nothing to learn here. You need to remember something. Okay, see, we have xt1 minus mu, xt minus 2 minus mu, xt minus p minus mu. We'll substitute everything. Even mu will take that side, and we'll make it xt minus mu. Okay, so we'll have xt minus mu, xt minus 1 minus mu, xt minus 2 minus mu, xt minus p minus mu. Remember, when I write nebula of xt minus 5, suppose 5 is a constant. Okay, that will be nebula xt, that's for sure. But how about nebula 5? It's a constant. If you write b also, b will push xt, bxt, that is xt minus 1, but b5 will be 5. If I write b here, bxt will be xt minus 1, but b5 will be 5. Okay, it will not be able to push backward. Okay, so mu is a constant. Then what will happen? So we'll take mu this side. Okay, and we'll introduce b here, b square, and we'll write that way. So this is my ARP. xt is equal to mu plus alpha 1 xt minus 1 minus mu alpha p xt minus p minus mu plus et. Here I'll bring mu this side. Okay, and that will be equal to alpha 1. Here I will write bxt minus mu. Here this will be bp xt minus mu. So I can take xt minus mu common. If I take xt minus mu common, I will bring everything this side except et. Then I will get this 1 minus alpha 1 b minus alpha 2 b square I forgot exactly we say theta b or phi b. Okay, it's theta b. Okay, because we'll use exactly whatever way, you do, so that you'll be able to remember. Theta means what? It's a function of B. We use this, so that's all. It's a function of B. And this is xt minus mu is equal to Et. We write this way. This is a function of B. That's all you need to remember. Okay. That's all you need to remember. It's bad. I think I have to start from one side. If I go, then it will work. Yes. Remember this one. This one is ARP. Okay. This is ARP general form, ARP process. But we'll go to ARP later. Now we'll start with AR1 process. And remember, when we say about AR1 process, I will always use this way. Xt is equal to, this xt is actually our xt minus mu. I will not write mu here. Directly I will write alpha 1, or because there is only one, we will start with alpha. Again, xt minus, let me write everything, okay? Because now it's okay. Later when you see, it might create a problem. This is AR1. Xt is equal to mu plus alpha 1. I've written alpha. This is AR1. But we'll use this way. Xt is equal to alpha xt minus 1. Remember, here in the second line, xt means xt minus mu. If you want, you can do with yt as well. Plus Et. And now, if alpha mod is less than 1, then this is stationary. Okay, remember, this is stationary if alpha mod is less than 1. If you want to know more about stationary, that will take half an hour. Okay, that I've decided not to start with today because I showed a lot of graphs. There is a chance of destruction. That is a bit theoretical. I will discuss more. I'll take another half an hour, maybe tomorrow, or maybe I will see the time. Okay, when it's appropriate, and I will bring. Just now, remember, stationary means variation is not. This is not stationary. This is not stationary. This zigzag is not stationary. Cyclic is not stationary. Stationary is something like white noise. Okay, white noise. Again, you have to see that if I make this way, this will not be stationary. Covariance will come through mathematical definition. We will see. Mean must be constant. Variance must be constant. Okay. Suppose I will write this way and then this way. Okay. So here the variance mean is constant. Plus minus mean is constant, but variance is not constant. Here you see covariance will come. How? From time to time, from this time to this time there is one way, from this time to this time there is one way. So through mathematical definitions I will discuss about this. Okay, maybe it will take half an hour, but not today, because we are concentrating and will be able to easily divert towards destruction. So alpha mod is less than 1. Just remember here, if alpha mod is less than 1, then this will be stationary. So if I give you some problems here, because for the next 1 hour or maybe next 2 classes, we'll most be discussing about stationarity. What is stationarity? Which is stationary, which is not stationary. That is what we'll discuss. Okay. So if I give you some examples to check for stationarity, I started with one today. Also, I showed you. I'll go to that, though that's not here. I deleted. So xt is equal to, suppose I will write 0.5 here. If I write xt is equal to 1 by 2 here, if I write xt is equal to 0.9 or minus 0.9 here, xt minus 1, xt minus 1, xt minus 1, and xt I will write 3 plus 0.2 xt minus 1 minus 3 plus Et. This is the general form. Plus Et, let me write here, and I'll tell you to check. I'll tell you to check for stationarity. Seeing all these, you can say this is stationary because alpha mod less than 1. This is stationary because alpha mod less than 1. This is stationary because alpha mod less than 1. This is stationary because alpha mod less than 1. We are not worried about 3. That is the drift of the process. Will go, we'll think about this later. You can just transfer it to this form, the earlier 1 to 3 form. Xt minus 3, you take yt. So you write yt is equal to 0.2 yt minus 1 plus Et. Again, 0.2 is alpha, so less than 1. So all are stationary. Okay. If alpha mod less than 1, why this is stationary? That is a question that I will discuss next time. Let's not worry about that. There is a second question. We assume something here. it has infinite history. Okay, that is an assumption. I didn't say you now. So it has infinite history. That is a meaning. I'll go to that. These are the 2 points. Okay, keep it pending. Suppose I will give you a time series like this. Xt is equal to 0.2 xt minus 1, then 0.3 xt minus 2 plus ct. If I give this one, then you will not be able to say anything here, because this is no more AR1. This is AR2. This is AR2. So if this mod less than 1 and this mod less than 1, this will not be stationary. Okay, so we have to know when ARP is stationary rather than AR1, and this is stationary, we can do directly. Okay, will not use any result. It's very easy. Maybe it will take 5 minutes time. AR1, they are stationary if alpha mod less than 1. Next class, whenever I will start with this one. I will prove if alpha mod less than 1, why this is stationary. But we'll use the general result for ARP.